Good morning to all my YouTube viewers. Today I like to discuss 2020's JEE Main's physics paper which took place on 8th January in shift-1. This is an extension video of the same paper. It will start from question number 9. Effective capacitance of parallel combination of two capacitors C1 and C2 is 10 microfarad. When these capacitors are individually connected to a voltage source of 1 volt, the energy stored in the capacitor C2 is 4 times that of C1. If these capacitors are connected in series, their effective capacitance will be, there are 4 choices. Solution: tools required equivalent capacitance in parallel and series combinations, and energy stored in the capacitors, that is half CV square. Now, according to question, when each capacitors are individually connected to a source of 1 volt, according to question it will be 4 times half C1 V square equal to half C2 V square. From here C2 is 4 times C1. Now, when connected in parallel, equivalent capacitance will be C1 plus C2, that is given 10 microfarad, that is C1 is coming 2 microfarad and C2 will be 8 microfarad. When they are connected in series, it will be C1 C2 over C1 plus C2, that gives us 1.6 microfarad. So, choice number 4 is the answer. Now, question number 10. A leak-proof cylinder of length 1 meter made of a metal which has very low coefficient of thermal expansion is floating vertically in water at 0 degree such that its height above the water surface is 20 centimeter. When the temperature is increased to 4 degrees Celsius, the height of the cylinder above the water surface becomes 21 centimeter. The density of water at 4 degrees Celsius related to the density at T equal to 0 degrees Celsius is close to, there are 4 choices, we will go for the correct one. Let cross section of the cylinder is capital A. By using displacement of water by the cylinder in it can be measured the weight of the cylinder at different temperatures. So, weight of the cylinder we can write A H1 rho 0 degree Celsius and W equal to A H2 rho at 4 degree Celsius. Equalizing these two, we can get rho at 4 degree Celsius and rho at 0 degree Celsius, that is H1 over H2. H1 means the immersed portion of the cylinder, that is 100 minus 20, similarly 100 divided by 100 minus 21, it will give you 80 by 79, which is 1.01. So, it matches with the answer number 4. So, answer 4 will be the correct one. Then question number 11. At time t equal to 0, magnetic field of 1000 Gauss is passing perpendicularly through the area defined by the closed loop shown in the figure. If the magnetic field reduces nearly to 500 Gauss in the next 5 seconds, then induced EMF in the loop is, there are 4 choices. Solution: tools required here is induced EMF relation, that is E equal to minus d phi by dt. According to the question, the area which is shown in the figure, that is constant, it has no kind of velocity. So, 16 into 4 minus 2 into triangular part, that is half 4 into 2, from here you can get 56 centimeter square, which is equal to 56 into 10 to the power minus 4 meter square. Now, from induced EMF relation d phi by dt, minus d phi by dt, it will give us minus a dB by dt, and we know minus 56 into 500 minus 1000 divided by 5 into 10 to the minus 4 into 10 to the power minus 4 will give us 56 into 10 to the power minus 6 volts, which is 56 microvolt, which is matching with the answer number 3. So, we can go for 3. Now, next question, question number 12, the dimension of stopping potential V suffix naught is photoelectric effect in units of Planck constant, speed of light c, and gravitation constant g, and ampere A is, there are 4 choices. After calculation it is found that there is no answer is matching with this, the answer which is coming, the expected answer here is h naught c to the power minus 1 g to the power minus 1 a to the power 5. Next question, that is question number 13. Consider a solid sphere of radius bigger and mass density that is given rho within bracket smaller, which is equal to rho naught bracket 1 minus smaller square over bigger square bracket close, and smaller varies from 0 to capital R. The minimum density of a liquid in which it will float is, there are 4 choices. Solution, concept of floating condition is required here, that force of buoyancy is greater than equal to weight of the sphere, and we can write here V rho of liquid into small g is the buoyancy force, which is greater than equal to V rho of solid into small g, where small rho of solid is rho as a function of smaller, that is equal to rho naught bracket 1 minus smaller square by bigger square. We know that weight we can calculate by integrating the small very thin hollow sphere within the sphere, that is 4 pi smaller square into thickness dr, and in multiplying rho is a function of smaller, it will give its integration limit will be 0 to bigger 4 pi rho naught 1 minus smaller square by bigger square into smaller square dr. Integrating this we can get 4 pi rho naught bigger cube over 3 minus bigger cube by 5. Solving this we can get 4 pi rho naught 2 by 15 r cube, which is equal to the buoyancy force of the buoyancy acts on the solid, that is 4 by 3 pi r cube rho into big L. Rho of the liquid will be 2 by 5 rho naught, which is matching with the answer 1. Next question, question number 14. The plot that depicts the behavior of the mean free time tau, time between 2 successive collisions for the molecules of an ideal gas as a function of temperature T qualitatively. Now, there are 4 figures given here. A solution, average time between 2 successive collisions, that is mean free time that is proportional to 1 by average velocity. Now, average velocity also known as root under 8 RT divided by pi m, that means if we put it an average velocity position, then tau is proportional to 1 by root under temperature T. When when temperature increases, 1 by root under T will decrease and tau also decreases. So, it is matching with the choice number 2. So, answer will be 2. Next question, question number 15. A particle of mass is fixed to one end of a light spring having force constant and unstressed length L. The other end is fixed. The system is given an angular speed omega about the fixed end and the spring such that it rotates in a circle in gravity free space. Then the stress in the spring is, there are 4 choices. Solution, tools required here, spring force, that is minus kx, k is the elongation, and centripetal force which develops on the body, that body has to provide, that is m omega square r. Now, natural length of the spring is L. Due to rotation with angular speed omega, angular velocity omega, it will elongate x. Force given by the spring on m will be kx, that is equal to m omega square L plus x, where r equal to L plus x. R means radius here. Now, from solving from this, we can get x equal to m L omega square over k minus m omega square. This one match with the answer 2. So, we can mark for 2. Next question is 16. Consider two solid sphere of radius r1 equal to 1 meter, r2 equal to 2 meter and masses big capital M1 and capital M2 respectively. The gravitational field due to sphere 1 and 2 are shown. The values of big M1 by big M2 equal to, there are 4 choices. Now, gravitational field for mass M1 will be G M1 over R1 square, and for M2 it is G M2 over R2 square, and these values are given 2 and 3. Now, taking ratios, we can see M1 by M2 will be 2 by 3, R1 square by R2 square, substituting R1 and R2 we can get 1 by 6. So, it matches with the answer number 1. So, we will go for answer 1. Now, next video will be coming maybe today's afternoon. If you find it is interesting, you can share, you can give comments, as well as you can subscribe to motivate me. Thank you very much to all of you, and my well wishes to all those who are taking challenges ahead of their ahead of the coming years. Thank you very much.